Nearly a third of the landmass in the Netherlands sits strictly below sea level. For centuries, the primary line of defense keeping the ocean out was a jagged 700-kilometer coastline, carved up by a complex network of river deltas and low-lying islands. On January 31, 1953, agricultural farmland was destroyed. The speed of the devastation exposed a fatal flaw in the country's water management. Patching old dikes and reacting to breaches was a strategy that could no longer ensure national survival. To prevent a recurrence, the government formed the Delta Commission. They adopted a strategy proposed years earlier by engineer Johan van Veen, a plan so ambitious it had been largely ignored before the disaster. Van Veen's plan relied on a geometric solution. To protect the land, they needed to shrink the target. By damming the outer islands together, they could replace the jagged inlets with straight lines, reducing the exposed coastline from 700 kilometers down to 80. Executing this vision required a massive economic commitment. The estimated cost of the project sat at 2 billion guilders, representing roughly 13% of the entire Dutch GDP at the time. This was an existential gamble. The country was betting its wealth on a feat of engineering that would physically alter the map of the Netherlands. Early construction relied on sheer mass. Engineers utilized phoenix caissons, rectangular concrete blocks the size of apartment buildings, floating them out into the waterways before sinking them into place. These blocks and millions of tons of boulders successfully sealed off major inlets, transforming turbulent tidal estuaries into calm, isolated freshwater lakes. But these static walls triggered a secondary crisis. By cutting off the natural tidal flow, the marine ecosystem suffocated. In places like the Grevelingen estuary, almost all the native saltwater life died within 3 weeks. Furthermore, blocking these inlets threatened the economy of the region's major ports. The waterways were vital shipping arteries for Rotterdam and Antwerp, and a permanent wall would have ended their ability to trade. The dams successfully stopped the floods, but they created new environmental and economic problems. The engineers realized that the future of the project depended on moving away from static walls in favor of something more complex. By the 1970s, pushback from local fishermen and environmentalists successfully halted the construction of the remaining permanent dams. The resulting compromise was the Oosterschelde barrier. It is a 9-kilometer structure built to stay open to the tides during normal conditions, but capable of sealing tight during a storm. The structure relies on 65 concrete pillars, each as high as a 13-story building. Suspended between them are massive steel plates that are lowered into the water by heavy-duty hydraulic cylinders when sensors detect a surge. The Oosterschelde barrier represents a shift toward dynamic infrastructure. Instead of blocking nature with solid barriers, the Dutch began building mechanical systems that remain open to the environment until the exact moment they are needed. The toughest challenge was Rotterdam. But rising sea levels are now changing the math. Current projections suggest that as the climate shifts, some of these barriers will face pressures they were never designed to handle by the end of the century. These rising tides have proven that even the most advanced concrete wall is a temporary measure. Long-term safety requires a strategy that goes beyond simple exclusion. To adapt, the Dutch have introduced a strategy called room for the river. Instead of fighting to keep water out, they are relocating dikes to create designated floodplains, giving the rivers safe places to expand. In Rotterdam, water management is built directly into the urban fabric. Residential blocks use elevated green roofs to capture rainfall, while public plazas are designed to double as emergency reservoirs during heavy downpours. This adaptation includes amphibious architecture, like these harbor pavilions. They are built on floating platforms that rise and fall with the tides, ensuring the structures remain functional regardless of the water level. The Delta works proved that the Dutch could halt a storm surge with steel and concrete. Today, that legacy has evolved into a system of active coordination, where the modern nation builds its future by flowing with the water rather than trying to overpower it.